A rational equation is an equation with two or more rational expressions. So to solve a rational equation, you need to do the following steps. First, we need to factor the denominators of all the rational expressions. After that, we need to determine the domain restrictions, meaning what will cause division by zero. But just like with the first video, I'm going to do this at the end. Third, I'm going to identify the LCD of all the expressions in the equation. And once I do that, I'm going to multiply both sides of the equation by the LCD so I can clear out the fractions and work with a simpler equation. Once I have my nice simple equation, I will solve for whatever variable I'm given, and then I'm going to see if one of my solutions is a restricted variable or a restricted solution. So first equation we have is negative 5 over x plus 5 equals x over x plus 5 plus 2. So I'll find my LCD, and I can see that it's an x plus 5 and an x plus 5 and a 1. Not too concerned with the 1, so my LCD is x plus 5. So now I'm going to multiply the entire equation by x plus 5. So this x plus 5 here is going to cancel out with this x plus 5 up here. And so I'm just going to end up getting negative 5. Now I'm going to do it again. Again, this x plus 5 is going to cancel out with this x plus 5. So cancels out, and I'm going to get just a plain x. And last, I'm going to multiply x plus 5 times 2. Since there is no denominator, it's just going to be 2 times x plus 5. So distribute the 2 across. Negative 5 equals x plus 2x plus 10. Combine the two like terms. Negative 5 equals 3x plus 10. Subtract 10 from both sides. And I'm going to get negative 15 equals 3x. And I'm going to solve by dividing 3, but I'm going to give myself some more space over here. So negative 15 equals 3x. Divide by 3. And I'm going to get negative 5 equals x. Now, is it a solution? I see that I have an x plus 5 in both, so I need to see if that'll give me 0. So plug it in. So negative 5 plus 5 equals 0. And that is something we cannot have. So since I can't have division by 0, I can't have this solution. So I have nothing else I can say as a solution. So this equation has no solution. Last, I have y over y plus 4 equals 32 over y squared minus 16 plus 3. I need my LCD, but on this one I have a slight problem. I got a y squared minus 16 that can be factored. It is the difference of squares, so y minus 4 and y plus 4. And so this doesn't quite fit here, so I'm going to rewrite the equation down here. So y over y plus 4 equals 32 over y minus 4, y plus 4, plus 3. And now I look for my LCD, and I see that I have a y plus 4 in both, or in 2 of the fractions. But I also have a y minus 4, so I'm going to need that as well. And now I'm going to multiply everything in the equation by my LCD of y plus 4 and y minus 4. So y plus 4 here will cancel out with us y plus 4 here. And so now I'm going to distribute the y minus 4 to the y, and I'm going to get y minus 4. Do it again for the next one. So the denominator, y minus 4, y plus 4, was going to cancel out with the LCD of y plus 4 and y minus 4. So gone and gone, and gone and gone. So what am I left with? just the 32. And last, I got a 3 here, and I need to multiply everything by the LCD. So there's nothing to cancel, so I'm just going to multiply the whole thing over. So I'm going to get 3, and I'm going to revert it back to what it originally was, y squared minus 16, just to make it a little bit simpler. Now I'm going to distribute the y inside and the 3 inside. So y squared minus 4y equals 32 plus 3y squared, and then 3 times negative 16 is going to be negative 48. I'm going to combine all the like terms by subtracting the y squared over here and adding the 4y over. So I'm going to end up getting 2y squared plus 4y minus 16. And I'm going to put the equal 0 over here, but if you put it on the left side, it's not wrong. I just prefer it to be on the right. I have a GCF of this whole equation, so I'm going to factor out a 2. So I'm going to give myself more space and move it over here. So 2y squared plus 2y minus 8 equals 0. Can factor out this quadratic, and I'm going to get y plus 4 and y minus 2. 2 equals 0 is just garbage, so I'm going to throw it away. But y plus 4 equals 0, and then y minus 2 equals 0 will give me something. So y is going to give me negative 4, and y is going to give me positive 2. But again, we need to check to see if it's good. Negative 4, if I plug it right here, I would get negative 4 plus 4 equaling 0. And that is something I cannot have. So negative 4 cannot be a solution. 2, on the other hand, I can do 2 plus 4, which will give me 6, which is a-okay. And I can do 2 minus 4, which will give me negative 2. Don't like negatives, but I don't care. It's not 0, so I'm happy. So since they both check out, or since 2 checks out in both instances, my solution is just 2.